Hello, Data. Welcome to a short 3-day week. I hope this finds you sunburned. You put on sunscreen yesterday in the beautiful 80 plus, maybe 90-degree weather. Pretty awesome. I do want to start out with a joke today. So this guy walks into the doctor's office and he was all upset. He's like, "Doc, you got to help me. I think I'm addicted to Twitter." And the doctor's like, "I'm sorry, I don't follow you." Uh, I laughed at it. That's pretty sad. All right. How do I find the surface area of cones, pyramids, and spheres? I'll do one example of each. Should be a short video, and you'll be on your way to do the practice. Turn it in and win yourself 1,000,000 points or 5. Okay, so we'll start off with, let's do pyramids first. I think the pyramids will be the best way to do it. All right, so a pyramid is like this. When you draw a pyramid, okay, you're going to draw the bottom like this, and you put a dot at the top. So basically, you draw a parallelogram, and then you put a dot way up high somewhere, right? And then you draw to the corners like this. That was not perfect, but you get the idea. And voila, we have ourselves a pyramid. Okay, so it might be better if I dot something like that. Okay, so the formula for the surface area of a pyramid is, well, you kind of got to think about how a pyramid works. And if I were to open this up and lay it flat, all right, so I'd have the bottom like this, and I have all the sides that would look like that. So the surface area is made up of 4 triangles and the bottom. So it looks like this. The surface area is the base, that's area of the base, plus 1/2 perimeter of the base times the slant height, L. And some of those things you don't know what they are yet. Let me teach you as I go. All right. So first of all, capital B, and I'll just write it in here. Okay, that is area of the base. Okay, that is perimeter of the base. And this is slant height. Okay. Now let me explain to you what those things are. So first of all, area of the base. So let's actually do this. Area of the base. So let's say it's a square here. Okay. And this area, let's say it's 5 inches on a side. So if I have 5 inches on a side, that is, with a square, is just length times width. So it'd be 5 times 5. So I'm just going to go 5 times 5. That's going to be the area of the base. So that's B. Plus 1/2. P stands for perimeter. Now, perimeter, in case you forgot, is just the distance all the way around. So if I were to walk from here to here, I walked 5 inches. And I walked from here to here, 5 inches. From here to here, 5 inches. Here to here, 5 more inches. So I've walked 5, 10, 15, 20 total inches, the perimeter of the base. So 1/2, 20, then times the slant height. Now, here's kind of tricky with the slant height. If I go from the peak right down to the middle, I should have made that line dotted because it goes to the middle. I can't really see it. I know it's there. That's called the height. It's going to make a right angle with the bottom. That's my height. But the slant height is this length right here that comes down the slant. So it's the height, but on a slant. It goes right through the middle of the side. Notice it's not the corner. The corner comes right down to the middle, making the middle of that side. So each half would be 2.5 down here. So that's the slant. I'm just going to tell you what the slant height is. We're going to call it 7 inches. Okay. So slant height 7 inches. And you'll be told that, or with the problems that we're doing, you'll be able to look that up. So all I do here is just plug everything into my calculator. Actually, I could probably do that by hand. 25 plus half 20 is 10. 10 times 7. Now remember, you don't have to distribute. You only distribute when there's a plus sign here. So no distributing. I take half of 20, call it 10, times 7 is 70. Right? Now, if you don't believe me, you could do half of 7 is 3.5. 3.5 times 20 is 70. So you can do it either way. All right. Now these are inches. This is all in inches, inches. So it's going to turn out to be 95. And let's see what the label will be. Inches times inches is inches squared, or inches times inches is inches squared. And that makes sense because it's a surface area, so it should be 95 inches squared. All right, so that's how you find the surface area of a pyramid. So I did pyramid first. These are listed backwards. We'll do a cone next, okay? So let's do a cone. I'll get you the formula for surface area of a cone. So let's just draw a cone. Cones are easier to draw. All you have to do is draw an ellipse at the bottom of a triangle and you have a cone. Let's put some lengths on it. Let's go here and make this be 4 inches. And let's make this length right here be 5 inches. I don't know why I'm working in inches all tonight, but we are. Okay, the formula for the surface area is the base plus pi r slant height. The base plus pi r slant height. Now, let's make that formula even better. Base is a circle, so the area of the base is pi r squared plus pi r slant height L. I don't know why they call it slant height. L being slant height, I don't know why it's an L, but that's what we use. And then we just plug everything. So everything in, pi times 4 inches squared plus pi times 4 inches times 5 inches. Again, slant height. It's on a slant. If I ask you for the height, that would go through the middle. We'll be doing that when we do volume. I'm not asking you for that. I'm asking you for slant height. And I put this all in my calculator and I get an answer. So let's actually do that. Okay. Can we see? Yeah, I guess we can see. Pi times 4 squared plus, I can type this all at once. Pi times 4 times 5. All right, notice I have inches times inches, so this would be inches squared here, plus some more inches times inches squared. So in the end, it's going to be answer is inches squared will be my label. 113.1 inches squared is my surface area of that cone. Okay, last one, we have to do spheres. Surface area of a sphere. Now, when we're in class, we do something fun with this, with oranges. I make you peel an orange because the orange peel is kind of like the surface of the orange. So number 3, let's say I have a sphere. I'm going to draw it. And I do this to make something look like a sphere. Draw an ellipse in the middle, kind of like the Earth's equator, right? So you have that equator going around the middle of the Earth. Oh, the Earth would be tilted a little bit. Oh, there's a little bit of tilt to mine. I could just do that. And then we have the Earth or that. I'm not very funny tonight. So let's say that the radius is, let's go something different. Let's go 10 meters. The formula for this, surface area. And in class, what happens when you peel the orange, you make a bunch of circles the same size as your orange. You find out that you fill up. When you peel the orange, you lay out all the peels in here. So you get all these little pieces of peel that you put in here that fills them up. Fills up 4 circles. So the surface area formula is 4 pi r squared. Surface area 4 pi times 10 meters squared. Now, when you do this for real, when you do this in your practice, you can actually leave your answer in terms of pi if you'd like to be lazy. And by doing that, your answer is actually more exact. So 4 pi 100 meters squared, 4 times 100 is 400 pi meters squared. And that's a completely acceptable answer. I could take my calculator, plug it in there, but I'm not going to because 400 pi meters squared is completely acceptable. It's exact, it's not rounded, and we like it. That is how you find the surface area of a sphere. Sphere being a ball, something the shape of the Earth, something like that. So we went over pyramids, area of the base plus half perimeter times slant height. We went over cones, which was pi r squared plus pi r l, which is the base plus the sides. And we did sphere, 4 pi r squared. And you have all these areas. Notice everything is squared with these. When I get into volume, it will be, surprise, surprise, cubed. Have a great day. We're almost done.